Hey, hello there. Today I'm looking at the question 210, course schedule 2, which can potentially be a follow-up to question 207, course schedule. For this one, 207, all the question is asking is about feasibility. So we want to determine whether it's true or false that we can finish the task described by the problem here. But for this potential follow-up question 210, not only that we have to determine this feasibility, if it's feasible to solve this problem, we have to return at least one of the answer. So that's why this can potentially be a follow-up to that question. But you really don't need to know 207 in order to understand 210. And actually, I'm going to do a different solution compared to my last video. So you can search for that video if you're interested in. So let's read the task. So we have to take n courses in total, maybe to either to graduate or get a certificate or something. And I guess just for the convenience, the courses are labeled from 0 to n-1. And as with real-life courses, they have prerequisites. So for example, if we want to take course 0, we first have to take course 1. And this kind of a prerequisite relationship is expressed as pairs of numbers. So the course indicated by the first number in the pair depends on the finishing of the course described by indicated by the second integer in the pair. And as input to our question, we're going to be given the two things: the total number of courses, that's the n, and also the list of prerequisite pairs. So we have a edge list inputs to us. So if we treat the courses of note, this input is basically edge list. And yeah, the question is asking us to determine is it feasible for us to finish all the courses, and if we can do so, it's asking for a one of the possible orders we take the courses. So that's the question. So just gonna talk about the feasibility very briefly first. When is it going to be impossible for us to finish all the courses? The only case is that there is a cycle. So course 0 depends on course 1, course 1 depends on course 0. Therefore, you couldn't really finish any one of those. So that's the only case where it's impossible to finish all the course. Otherwise, we can just try to finish finish all the prerequisites for a course, and then that course will be available to us, so we can take that. For any course in this system, in this program, as long as there is no cycle, we can eventually finish all of them. So that can lead to potentially multiple different orders. But as long as there is no cycle, we can at least find a final order. So two things that just briefly touched by my description about how to reasoning through here is that the code has to be able to handle two things. One is to detect the cycles. That's the indication for if there are is it possible or not. The other thing is we want the correct order, which is basically just taking all the available course that's currently available to us, and but keeping an eye on the course that have prerequisites. Once we finish the prerequisites for one particular course that has some prerequisites, that course become available to us as well. So that leads to a very simple BFS Search kind of a solution. So just going to show the graph here. Here, as with real college courses, the courses can have levels. Usually, the level is usually the number of courses that it depends on. You have prerequisites about. So here I have 3 different level of course. And you can see that course 201 have a prerequisite 101 and 102. Yeah, maybe 101 is linear algebra, 102 is probability series, and 201 can be maybe machine learning. 301 might be deep learning. So you have this kind of a layered or leveled course systems, and if we do have cycles, 101 depends on 201, 201 depends on 101, then there's no way that we can finish this. Otherwise, the strategy is going to be level by level, BFS Search. So the way we do that is to first find out all the courses that we can take, so that those courses without any prerequisites, and then just they're gonna take them in sequence. Whenever we finish our course, the thing that we want to do is to look at the course that depends on it, so we can follow this prerequisite kind of the follow-up links. So we can convert this from convert the edge list into this kind of format, out edges, and looking for the course that depends on the one that we have just finished. And since that we have already taken that, we can decrement the number of prerequisites that course has. So in this example, once we finish 101, we're going to decrement this counter by this number of prerequisites by 1, and mark 101 as taken. The second course we take is going to be 102, so we will move this from this can take. So as you can see that we are popping from the left, it's going to be a queue. Move that to taken, and at the same time we're going to decrement the count for the number of prerequisites for course 201. So once this counter, number of prerequisites reduced to 0, that's the first time we're going to append this to the back of the queue. So that's just the simply meaning that after we finish all those prerequisites, we can now take 201. I'm just gonna keep resuming this process, keep continuing this process. Take the first available course and decrement the count for the course that depends on it. And when we satisfied all the prerequisites requirements for one of the courses, we push it back to the queue. And basically just gonna repeat this process until we run out of finish all the course. That's the time when the queue will become empty. After we finish 205, we can decrement the counter for the number of prerequisites for 301 and push it back onto the queue, and immediately after that we're going to finish it. And this is the terminal course, and after we move that onto taken, we pretty much finished all the courses and also come up with an order to actually taking all the course in sequence. So so this is pretty much an animation about how we're going to do BFS search to solve this. To do this, we need two things. One is the out edge. So instead of the course depends on which one, it's going to be the course. It's a prerequisite for another course. So we're going to convert the edge list into this kind of convert the edge list into a adjacency list, which is going to be the course, and it's a follow-up courses in that kind of format, so that we can follow the links to decrement the counter for that. So the counter here, the number of prerequisites, is basically the in degrees for every node. So we need two things. One is edge list out edges, and the other thing is the in degrees. And with that, we're just going to do the BFS search. The order that we put the course onto this data structure, this container, is going to be the order we take all the courses. So if there are a kind of a cycle, so if there are cycle, that means it seems like let me just try to illustrate why this solution also guards against the cycles. So if there are cycles that for example, the course 201 is dependent on 301 by maybe screwed up, someone designed a curriculum and screwed up this dependency, then after we finish 101 and 102, the course 201 will still have one course it has as a prerequisite. So this 201 will never be moved to taken. So the length of this taken will be less than n. So in the end, after we're done with the BFS search, if the resulting array has a length that's less than n, that means we still have course we couldn't finish because of this cycle dependency. So that pretty much summarizes how we're going to solve 210 using this BFS search. I think this is called Kine's algorithm for topological orderings, but you really don't need that. It's pretty natural to think about this as relate this problem to real life college, curriculums. You have different levels of course, and just try to think about it naturally, how you're gonna choose your courses to fulfill your degree requirement. You're going to do the lower level course first and look at keep an eye on what you can potentially take in the next semester. Once you finish all the prerequisites for one of the course, you can add that course into your consideration about the course you're going to take next. So it's a very natural intuition about applying BFS Search on this problem. So with that analysis, I'm just gonna code this thing up. So before we actually code, let's resume the habit that I kind of forgot in the past months to analyze the time and space analysis. For the time complexity, basically the thing we want to do is to convert the edge list. Convert the edge list into edge list. Can convert the edge list into the out edges. So from the pairs of numbers into from 101, I go. It leads to 201. It potentially leads to some other courses. So if you have errors of that, so it's going to be list of list. And that takes the time corresponding to the number of edges, and it takes up the space of corresponding to the number of edges. The second thing is to count the integrity for every node. We can do that in the same time as we convert the edge list. For doing that, the time is going to be equal to the number of edges. The space is going to be, we're pretty much annotating every node with a number, so it's going to be taking the number of, the space is going to be the same with number of nodes. So that's the processing. It's going to be linear with respect to the number of edges, and it's taking up a space that's V plus E. And once we have that, we can do BFS search. So to do BFS search, we're going to visit every node exactly one time. So move that from can take to taken. And so that the time complexity is basically the number of nodes plus number of edges. Yeah, so that's that. With that, I can start code. So we're going to do this. It's going to do out edges. So it's going to be a dictionary or array. It should be fine because we have this n, we know this n ahead of time. And the second thing is in degrees. So that's the number of prerequisite course we haven't finished yet for every course. So let's also use a list here. So we're going to be 0 for every course in the beginning. Then we're going to process do some processing of the graph. So the dependency is that for the actual course and its prerequisite. So course prerequisites. Let's be more readable. We're going to do two things. One is to populate this out edges. So the prerequisite will be adding this course as its follow-up course, and then we increment the degree counter for the course by 1. So this course have one more course that we identified as a prerequisite. So this is the graph processing. So that's that. Then the thing is now is to do BFS search for feasibility as well as order. So we do two things at the same time. So we're gonna have a queue, That's the courses we can take in the beginning. So that's course for course and the number of prerequisites. We enumerate over the in degrees. So we're gonna come up with the course number and the number of prerequisites. We're gonna filter that to include only those courses we can take right away, so the course that has 0 prerequisites. So that's gonna be, let's be more readable. So if the course has no prerequisites, so we're gonna start with those as in the beginning. I think I need a queue, a deck for this. The list the pop from left is too expensive. And then it's gonna be the BFS search. So it's gonna be course equal to popping from the first available from the left. Let's have something like a taken, which is deck as well. Do we need it to be a deck? Let's look at the graph. I don't need to be a deck. It can just be a stack. So we push on to the end of it. So whenever we pop a course up, the thing we're going to do is to add that to taken. And then once we're taking it, we look at the course that depends on it and decrement the count for that. So we're going to decrement the count. If the course is if we have finished all the prerequisite for this course, that's the time we can move this next course onto the available course to us. So that's that. And in the end, we just return the taken if it has the same length as the number of courses that we need to take. Otherwise, we return what's required by the problem, empty array. Yeah, so that's this problem, I think. Let me try to run this code. It's working in this case. Let me try if it can detect the cycles. So we can add 0, 1. So we will never be able to finish either one of those courses. It's returning empty space, empty array as well. Add one more course. 1 depends on 0, 0 depends on 2, and maybe 1 depends on 2 as well. So we can still finish. It's just that we have to finish 2 first, and then 0, then 1. So that looks okay. So it should work. Yeah, it's working. So this is the BFS Search to solve this question 210, and it can also be used to solve 207 as well. All you need to do is to return this as a boolean, so you will be able to solve this feasibility problem. If you're interested in checking about the DFS Surge solution to solve this problem, you can look at the video 207 that I had. Potentially I could put a link there. I don't know if I will really do that. That it's slightly more complicated actually, but it's more space efficient. And it's also easily adaptable to solve this question. So let me actually just do that. Go ahead and do that. So just copying the solution from 207. Maybe as a real interview settings, this question do come up as a follow-up. We just need to modify the prior solution and try to adapt it to solve this new one. So the thing that we want to do is to also keep a vector. Sorry about the switching languages, but here basically is that I want to have something that keep track of the order where I take courses, and so it's push back. And here I'm just gonna do, if I do have cycles, that means it's not possible. I will return the empty list. Otherwise, I want to do the reverse, because in DFS Search we are pushing, we append the course in the backward order. So instead of doing this 101, 102, 105, if we do DFS Search, get rid of this. It's basically try to go as deep as possible. And once we reach dead end, that means that course has to be taken in the last step. So we push that onto the stack. But in the end, we have to reverse that. So it's going to be 301, 201, and 101, 102, 205, and 105, something like that in the order. So that we have to flip the order in the reverse order to get the true answer. So let's see if it works. It's working. Okay. Yeah, so that's the DFS Surge solution. If you're interested in knowing the detail, the reasonings, and some illustration about how this works, you can check out my video about 207. But for my personally, I do think that the BFS Surge solution I showed here is more intuitively easy to understand, even though it's more demanding, because it requires the more processing, a little bit more processing to get the in degrees. But it's very intuitive to understand the BFS Surge solution to this topological sort problem. Yeah, so that's it for today.